all of the turning and veering required for the actual traversal of the game board. This was a lot of debugging and a lot of fine calibration because a small change in the weight, so the battery size, or a small change in the amount of current actually going to the motors caused huge calibration issues. So this had to be recalibrated repeatedly with every small change of our robot. But that was my role.
All right, so I was the hardware lead. I selected most of the components, be it the ultrasonic sensors to detect if an object was in front of you or not, the IR sensors for the line following, also the H-bridge so that we could control the robot, and the motors so that they were both strong enough to move the robot, but also small enough to fit in this tiny footprint that we had to do. Also, I created all the mounting hardware so that we could fit it in this robot. Now here's our video. In the video, you'll see the game from startup. So the pieces will start on go. It will start, and then you'll see the gameplay start going. You'll see the pieces in the VR game going. It starts in the 2D view, the top-down view, and then it will cut back and forth between the 3D view and the board. Again, you'll see the pieces moving around. It'll cut in and out of that a few times, and it'll end up cutting back to the robot, actually going across the board, following what's going on in the game, turning around the corner, and a picture of Zach playing the game as it's happening. Okay, so we installed it down in the lab. We'll be bringing it back up here for the presentations later, so you guys can check it out. We briefed Professor Kia basically on how it works, how to set it up, as well as he was very curious about how some of the logic and how the game actually worked internally. So we explained quite a bit of that to him, and overall he was pretty happy with the project.
In conclusion, it was a really enjoyable project connecting the Oculus with the robots, and we really want to work on making the robots like a smaller package so there's not just a mess of wires in the robot. And then we just want to thank all the professors, GTFs, everyone for helping us. That's it.
Questions?
What's the cost per robot?
As it stands right now, the per robot was definitely less than $100, but it's extremely variable because actually most of the cost for it, almost half the cost, was related to shipping because all the components themselves were actually very cheap, and shipping ended up being as much or at least close to the actual cost of the components themselves.
Professor Hornstein?
Very nice piece of work. A couple of questions. Did you build one robot or more than one? And secondly, perhaps I missed it, but how is the robot talking to the virtual world, the computer? Is it a Bluetooth or something else?
Yes.
Okay.
Yeah. So the Oculus writes the command to a text file, and the Bluetooth dongle. There's a Bluetooth dongle of the computer and a Bluetooth module on the robot, and it sends the command to the robot. And then we have two robots, but one of them isn't working right now.
It had the flu today.
Yeah.
Very good. Thank you.
What's the battery life of the robot?
The battery life is variable. We had it running on on actual, what are they, like 3.7 volt batteries. But we ran into concerns with burning out the Raspberry Pi because the connection to power the Raspberry Pi not be a USB cable. There's no really overcurrent or over voltage protection. And so in order to mediate that and be a little bit more cautious, especially with our timeline at the time, we decided to run it off the portable power supply.
Like USB, like phone charger things.
So right now it's variable on how big these are, but it's actually very low power consumption though.
Well, on average, how long would you say would it last for like a game, or would it last for
Yeah.
It would definitely make it at least a game.
Yeah.
at least a game? Yeah.
Yeah. Our games typically aren't that long, so we simplified some of the logic for Monopoly. Like, basically the game ends if one player runs out of money. There's no like debt management system or anything, so the games kind of end quicker than a typical Monopoly game would. But yeah, it would last a full game.
Just one more. And so to control the robot, is it a location on the board that you send the command to, or is it a distance in the direction?
So the way that we do it, we send, the robot just moves around the board like any piece would. It only goes forward. So what we end up sending it is, when we write from the game out to the file to send, we write first the ID of the robot that needs to move, then the number of tiles it needs to move, and it counts the spaces, and then finally the distance to the first corner so we know when to turn.
So essentially it knows where its position is, and then corners are specialty game spaces because they have to do special turning functionality. So we just need an identifier if it is currently on that game space or if the corner space is in its trajectory anywhere. And so essentially that's all it needs to be aware of other than its destination and current position.
Thank you.